All right, we're going to be talking about, instead of finding the arc length, we're going to be talking about finding the area. So when it talks about sector area, so if I have a circle and I have a central angle, that means an angle coming out from the center of my circle. This right here, this pi piece, is called the sector, a sector of a circle. As long as the vertex of that angle is the center of the circle, this pi piece is called the sector. So we want to find the area. Our last section we were finding this length right here along the edge of the circle. Now we're going to be finding the entire area of that pi piece. And the method that we're going to use is the exact same as the previous section. Only instead of comparing it to the circumference, we're going to be comparing it to the area of the circle. Otherwise, it's the exact same format. So, to find simple sectors when our degrees is really nice, easy fraction, we can use fractions. So, example 1, we're going to find the area of the shaded section. I don't know if you can see that, it copied kind of dark, but that central angle is 60 degrees. Ooh, I know 60 degrees is going to make a really nice fractional part of my entire circle because there's 360 degrees in the entire circle. So I know that I'm going to be comparing it to the entire area of the circle, so I need to find the area of the entire circle first. So I do need to do that. I know the formula for an area of a circle is pi r squared. I know that the radius in this case is 8. So pi times 8 squared is 64 pi. So the entire area is 64 pi. Well, I know that 60 degrees is 1/6 of the entire circle because I know that there are 360 degrees in a circle. 60 over 360 is 1/6. So basically, I know that this area will be 1/6 of the entire area. So 64 pi divided by 6. I'm going to reduce that because we always reduce. I'm going to divide by 2 2's and I get, what's that, 32 pi over 3. So this would be my exact amount, and this does not have units, so I'm going to write units. And since we're dealing with area, it's always going to be squared, units squared. And then again, if I want to round it, I'm going to do 32 pi divided by 3. Let's round to the nearest hundredth. That's going to be approximately 33.51 units squared. There we go. So that works if your degrees is going to make a really nice fractional part. And again, a lot of times our degrees are not going to make nice fractional parts. So in that case, we are going to set up a proportion. And just like last time, we are comparing part to whole. Okay? The ratio of the arc area or the sector area to the entire area of the circle is going to be the same value as the degrees of your central angle over the entire degrees of your circle. So let's go over this example real quick so you can see the steps. In this example, I know that the radius is 7. I know that my central angle is 100. It's not going to really make, 100 isn't a super nice fractional part of 360. So I'm going to set up my arc area or my sector area over my entire circle. And that's going to equal my central angle over 360. This is your general proportion. Now we're going to fill in what we know. My arc area or my sector area, I don't know what that is. I could call that x. I do have to figure out my circle area. So over here I would write my circle area is pi r squared. That's going to be pi times 7 squared, which is 49 pi. That's where we get this 49 pi. So x over 49 equals, my angle is 100 degrees over total angles is 360. So if I were to rewrite this a little nicer, it would look x over 49 pi equals 100 over 360. That would be my proportion. Now our next step is cross multiply. Doot, doot. That's where we get 36 times x equals 49 pi times 100 is 4,900 pi. We're going to solve, so I'm going to divide both sides by 360. That's where we get 4,900 pi over 360. And again, if I want to keep my exact answer, I would just keep pi in there and simplify the fraction 4,900 over 360. But the approximate value is 42.76. Remember your units. And units here is centimeters, so centimeters squared. And this is just a reminder that we are going to be using the formula for area, which is pi r squared. All right, let's go through example 2. Find the area of the shaded sector. I'm going to find this whole little pie piece here. I know that my central angle is 50 degrees and my radius is 6. Well, I am comparing my shaded area here with the area of the whole thing, so I'm going to start by finding the area of the circle. Pi r squared, my radius is 6. That means my whole area of my circle is 36 pi. I'm just leaving my exact answer as 36 pi, and I'm going to round it at the end. Because if we round this and then we use our rounded answer to find another answer, our answer gets more and more and more off of the original value. So it's better to use your exact value until the end if you can at all. All right, so the whole thing is 36 pi. Now I'm going to set up my proportion. My sector area, my shaded area, over my total area, that would be the area of my circle, equals 50 degrees over 360 degrees. I'll just kind of fill this one in. My sector area, which I'm going to call x, my total area is 36 pi, equals my central angle over total angles. So that is my proportion. I'm going to cross multiply. I get 36 times x equals 36 pi times 50. I'm going to go over here. I'm running out of room. That bothers me. 36 times 50 is 1,800. So I have 360x equals 1,800 pi. Sorry, little circle, I'm writing on you. I'm going to divide by 360. And I have x, my sector area, equals 1,800 pi over 360. I'm going to try to simplify this so I can get my exact answer and my rounded answer. So those are gone. I have 180 divided by 360. I could probably divide by 18. 180 divided by 18 is 10 pi. 36 divided by 18 is 2. Oh, I could have divided by 36. That equals 5 pi. Oh, nice. I'm going to check that just to make sure because my brain is super tired today and I am known to make dumb mistakes. Yep, that works. All right, so that's my exact answer. And then 5 pi approximately is 15.71. And then I don't want to forget my units. So that would be yards squared. I'm just going to write 1 yard squared for both problems. There we go. All right, so again, major goal in this one is can you set up your proportion? You are comparing your part over whole equals part over whole. So the very similar method as with the last section, if you can set up your proportion, you can easily solve any of these problems if they're icky numbers or nice numbers. Have fun.